All right, let's dive in. Today, we're going to pull back the curtain on one of the most powerful technologies shaping our lives right now. We're going to build a really clear, super simple understanding of how a machine goes from just looking at a pile of data to making some pretty smart predictions. Let's get to it. You've probably wondered about this, right? You finish a movie, and bam, almost instantly, a new recommendation pops up that feels, well, perfect. How on earth does it do that? Or think about your email. Somehow it just knows how to filter out all that junk, keeping your inbox clean. It really does feel like magic sometimes, but it's not. And this gets us to the real heart of the matter. Is there some programmer somewhere typing out every single rule for what's spam and what isn't? Or is something way more interesting going on? Is the machine actually learning all by itself? That's what we're here to figure out. You see, the secret isn't some single brilliant action. It's actually a continuous process, a loop. So let's start by looking at the basic cycle that powers this whole thing. When you boil it all down, machine learning is really a pretty simple, powerful loop. It works like this. First, you feed the machine a ton of data, just loads and loads of examples. Second, it crunches all that data to find patterns and builds what we call a model. And third, it uses that model to make an educated guess, a prediction, about something totally new. Data, model, prediction. That's the loop. Okay, so we know it finds patterns, but where does it, keep them? Let's peek inside the machine's so-called brain to see how it's actually built to think. So this brain is usually something called a neural network. And I know that name sounds super technical, but don't worry. All it is a computer system made up of little virtual neurons that all work together. It's actually inspired by our own brains, where different cells team up to process information. So here's how it's laid out. Information comes in through the input layer. Then it gets chewed on and processed in the middle through what we call hidden layers. And trust me, this is where the real magic happens. And finally, a decision or a prediction comes out of the output layer. But here is the actual secret. The magic isn't in the neurons themselves. Nope. It's all about the strength of the connections between them. Every single connection has something called a weight, which is basically just a number that tells the network how important that connection is. You can think of it like a giant control panel with thousands and thousands of tiny little knobs the machine can turn up or down. And adjusting all those knobs is exactly how the machine learns. But of course, that brings up a really important question. I mean, think about it. If it makes a wrong prediction, it needs to adjust those knobs to do better next time. But with thousands, maybe even millions of them, how on earth does it know which ones to turn and which way to turn them? Well, it all starts by measuring just how wrong it was. It uses something called a loss function, which is just a fancy name for a formula that calculates an error score. If the guess was perfect, the score is 0. The more wrong it was, the higher the score. The machine has one single goal: get that error score as low as humanly or machinely possible. To get a feel for how it does this, let's use an analogy. Imagine all the possible ways you could set those thousands of knobs creates a giant landscape. And the error score for each second is just the height at that point. A really high error is like being on top of a mountain, and a really low error is like being at the bottom of a deep valley. So the machine's goal becomes pretty simple. Find the absolute lowest point in that valley. But here's the catch. It can't see the whole map at once. So instead, it just feels the ground right where it is, finds the steepest downhill direction, and takes a small step. It does this over and over and over again, always stepping downhill until it finds the bottom. So how does it figure out which way is downhill? Well, that's where this complex-looking formula comes in. It's part of a process called backpropagation. Now, the math itself is intense, but the idea is simple. It works its way backward from the final error and figures out exactly how much each and every little knob contributed to the mistake. It's like a GPS that tells the machine precisely how to adjust each knob to get a better result next time. This is the engine that drives the learning. So the machine has a brain, it can measure its mistakes, and it knows how to correct them. But none of that matters, not one bit, without the single most important ingredient of them all. There's an old saying in computer science, and it has never, ever been more true than it is here. Garbage in, garbage out. A machine learning model is only as good or as bad as the data you train it on. Simple as that. And this is why it matters so much. If the data you feed the machine is biased or messy or just plain wrong, then the patterns it learns will be biased, messy, and wrong.
and its predictions will be unfair or just inaccurate. But if you train it on clean, fair, and well-labeled data, it can achieve incredible things. The quality of the data is truly everything.
Okay, so we've covered a lot. We've gone from a simple loop to neural networks to error scores and downhill valleys. Let's bring all this complex math back to the real world, to the things you actually use every single day. That whole learning loop we talked about, the data, the model, the prediction, and the correction, that's the engine humming behind the product recommendations you see online. It's what's catching spam in your email. But it also powers much bigger things, from helping doctors diagnose diseases earlier to helping companies sort through thousands of job applications. This process is already a huge part of our world.
And that kind of leaves us with one final big thought. This entire process, all of it, runs on data. Data that we create that reflects the world as we record it. So as these systems get better and better at learning from that data, the real question becomes, what are we teaching them about ourselves?